Right, good morning. So clearly yesterday there was a session here on functional programming, and I'm guessing that we were talking Haskell. The problem is this won't compile because Haskell is case sensitive, so always keep these things in mind when you're writing stuff up on these. And actually I think that in here there was a deeper subtext about Brexit. Maybe just nothing. Maybe that's what we're saying. I don't know. I'm not a betting person. I am going to talk a little bit about probabilities and estimation, but I don't bet. But it is interesting that if you actually want to know, I keep getting asked as I travel, Kevlin, what's happening with Brexit? Because originally it was going to be today, which is why I booked an earlier flight than normal so that I could make sure I could actually travel. And people keep asking me, Kevlin, what's happening with Brexit? And I say, well, it's a little bit like the weather. If you ask me what's the weather now, I'd say look out the window. Because, in 5 minutes' time, it could be different. So it does actually turn out the best way to find out about Brexit is to go to the betting sites. They have far better insight on the probabilities. So it's quite interesting watching those change. Anyway, curiously enough, we're not here to talk about that, but I might be mildly obsessed with it. We're here to talk about this. Agility does not equal speed. And I want to talk about, therefore, what we mean by speed. I also want to talk about what we mean by agility. And there you go. I'm easily stalkable. So I have an interest in a number of things. Software architecture, patterns being one of them. But one of the things about patterns is that they are intended to be empirical. This is a subtlety often lost on people, that you're supposed to try something and say, well, hang on, does this work? Is this the right context for this? They're not supposed to be a blind application of some kind of blueprint. That is definitely not about it. So there is this idea of exploration. And in the original patterns work by Christopher Alexander, and patterns came not from software but from building architecture, Christopher Alexander advocates an approach that he calls piecemeal growth, but we would call typically iterative and incremental development. Okay, he's sort of saying, well, you have an idea about how a building might turn out, but you need to treat that as a little more exploratory, contingent, and actually see whether or not your design works in the context as you are building it, and whether or not people come up with new ideas as they are building it. But I'm also very interested in the detail, because that's where systems happen. When we talk about architecture, where does architecture happen? It doesn't happen in some kind of vague atmosphere of possibility. It actually comes down to actual code. When we talk about agile development, a lot of people have got distracted by management practices and process practices, forgetting that that is all in support of something, and that thing is the software. People are focused on the agile, but not the software development. It is the manifesto for agile software development. And that's kind of important. It is there to serve a purpose. This happens in the detail, and the detail is where the surprises happen. Details like case sensitivity. And if you have a good eye for detail, then you spot things in the real world. For example, a couple of years ago, I received a package. And my wife said, are you going to open it? I said, hell no, not until I've taken a photograph. The world is filled with beautiful coincidences, so I thought I'm going to take advantage of this. But it also allows us to figure out, okay, what do we mean by this stuff? What is this stuff agile? And we can go out and look on the internet and sort of look at the various standard responses to do with agile software development, but I'm kind of a dictionary guy and a words guy. So I'm going to go and dig in my dictionary. And it already tells me a lot more than most books on Agile do. Agile, first thing, it's an adjective. It's a very simple observation. Yet the point here is that it tells you that it is not a thing that you can do, it's a thing that you can be. You don't do Agile, you can do Scrum, you can do XP, you can do Kanban. But you are, you are more or less agile than perhaps you were 6 months ago. That team is more agile than that team. We can also apply it to other things. Because it is an adjective, it is a property of something. It's an observable property, so therefore we need to observe. Okay, this is a very, very important idea. So organizations that are doing agile transformations, it's just a kind of often missing the point. This is this piecemeal growth. It doesn't just apply to the things that we build, it applies to the way that we interact. And this is quite important. So we need to observe. Observation will tell you an awful lot. We can apply it to code bases. We can apply it to architectures. We can apply it to organizations because it has a very simple meaning. Able to move quickly and easily. And I'm able to say, it's no use me having an agile mindset if my code has a very different opinion of that. Okay? It's just like, hey, we're an agile team. We're totally, we're going that way. And the code says, you're going that way. Yeah? This is a really important point, that the thing that you are working with also has to play along. A few years ago, I picked up the small piece of trivia that the turning circle of an oil tanker is around 5 or 6 kilometers. So if you've forgotten your keys, that's tough. The turning circle of a skateboard is like 0. Now, this is an important consideration because there's something else here that's going on. We've got this idea of able to move quickly and easily. It's those two properties. These are observable properties. Now, what's really interesting here is that most of the time when you hear it, somehow the second bit gets forgotten. They just go for the speed, the quickly. We were here before, 25 years ago. Rapid application development, RAD, or Rabbit application development. There were issues with quality. Mistakes were made. But this is how we tend to focus on these things. And this all fits in with a kind of a general emphasis on something that is more immediately observable, which is speed. And this also relates to the thing that we build. So Blaise Pascal wrote this. I've made this letter longer than usual because I have not had the time to make it shorter. I've seen this attributed to all kinds of people. It is Pascal. It is Blaise Pascal, because you can actually find the original French. It was written in the 17th century. So if, the internet is filled with possible alternatives. Yeah? So there's no maybe. This is the truth. The most interesting thing here, when we start talking about things like quality and the scale of our code and the complexity of our systems, it turns out that it all hinges on something that we are surprisingly poor at dealing with, something that we live in and yet do not fully appreciate. Time. It's a little bit like we didn't really understand air until relatively recently, and yet humans have been breathing air for a really long time. We live in time, but we're very poor as creatures of time at understanding how it works. And this leads to all kinds of really interesting thinkers and shortcuts. So this is an experience from a couple of years back. I was talking to one developer. He said, I can't get this code working. Well, did you check it before integrating it? Yes, I checked it in the interpreter. Did it work there? No. It's kind of like he's in a hurry. He's kind of like, there's a notion here of urgency. It doesn't work there, so maybe it'll work here. This is a brilliant thing. This is the opposite of it works on my machine. It doesn't work on my machine, but maybe it'll just work in production. Just this, people don't pay enough attention to the opposite of it works on my machine. And that sometimes people, production, it's special. It's got magic fairy dust that makes things work. Maybe it'll work. And this also hints at something else. We're terrible. We are optimists. Otherwise, you wouldn't be doing software development. Yeah, honestly, it's baked into your DNA. But this urgency that drives us to do things which, when presented in the cold light of day, look clearly, well, that's ridiculous. Why would you do that? People don't present themselves or the things that they do in life as little stories to be told in talks like this. That's not how it works. That's only an observation after the fact. What happens is that you are in the moment, and our ability to understand the pressures on us are not very good, and the urgency, the speed. We also have mantras that kind of encourage us down this path. Now, Facebook didn't come up with this. This is actually an old engineering adage, move fast and break things, which is absolutely brilliant until you start saying, let's break politics, or let's break client dependencies, let's break all of these things. There's a notion here, the obsession with speed, again. And this is a problem, because it turns out that this is really, well, actually, let's put it this way. A lot of people don't call it speed in the Agile space. They call it velocity. Now, somewhere in my deep and distant past, I have a degree in physics, which makes me very upset by this, because these are not the same. It turns out that velocity has direction. It turns out that matters. And what most teams, when they are talking about velocity, are talking about is magnitude, but not direction. They are talking about some notion of speed. Direction matters. I had this experience a number of years ago, driving, trying to navigate, let's see, Belgium, Netherlands to Germany. I was driving. This is pre-Google Maps, and I didn't have a sat-nav on me, so I just relied on Microsoft Autoroute. Yeah, I know there are Microsoft employees in this room. I want you to feel embarrassed. Microsoft Autoroute, which it turns out has a little bit of an issue with localization. It has this rather sweet idea that there are only two languages you ever need to worry about. The language of deployment, in this case English, and the language of the country that you are driving in. That's great if you have a country with only one language, but when you are driving through Belgium, this does not work. And unfortunately, it turns out that all the names that we have in England for places in Belgium are the French names. This does not work when you are not in the French-speaking part. So I'm there driving, thinking like, hang on, I'm trying to figure out, is that the same there? And then I see the sun. The sun is in the wrong place. I'm driving at speed around the ring road, and I'm sitting there, I've got good speed. I'm looking forward to the speed that I will get when I cross the German border, but I've got great speed, just in the wrong direction. The sun is not where it should be. It turns out I would have been better walking at that point. This is important. A lot of teams are heading in the wrong direction. And what do we mean by the wrong direction? Well, sometimes we're talking in terms of the product feature set. Sometimes we're talking in terms of the organizational goals. Most often and most visibly, we're talking about the internal qualities of what they are building. We're tearing up at great speed. We are just massing up technical debt. We are building the wrong thing in the wrong way. And we are going to pay the price for that one day. So there is this idea that we need to care a little bit about direction, but even if we reduce it to just the speed dimension, that gives us a question. What do we mean by the speed, the magnitude? It's displacement of stuff with displacement of S with respect to time. More formally written like that, but let's keep it simple. My younger child is doing the SUVAT equations at school, so let's keep it nice and simple. So we need to figure out what S is for us. T is for time, V is velocity reduced to speed, S is stuff. Now you can stop me if you think I'm getting too technical. It's stuff. It's the amount of stuff per time. Now we need to figure out what the nature of stuff is. One way of dealing with this is stuff we have left to do. And this is a burn-down chart. Stuff we have left to do over time. Here's an idealized burn-down chart. We have less stuff to do. Burn-down charts can be very useful. I tend to focus more on build-up charts. How much stuff have we done, or how much stuff have we got? There's another way of looking at it. If you want to combine both views, you can do things like cumulative flow diagrams. But I'm not really here to talk about the diagramming exactly as the nature of the axis that we're dealing with here. I mean, first of all, I'm a little bit suspicious whenever I look at diagrams and they have straight lines. The real world doesn't work like this, but also there's this notion that having a constant speed is necessarily a good thing. Actually, I don't think it is. If you're undertaking work that is new, that is novel, and you've never dealt with before, constant speed is not really where you want to be. You want to be picking up speed. You want to start slow and comfortable, and as your knowledge increases, you want to be picking up speed. So actually, starting at that speed is not really where you want to be going. But there's another interesting thing. We might have to be a little more precise about the word stuff. And what is the nature of stuff? What is it that we are accumulating? And this is where it starts getting tricky, because in the world of physics, it turns out there's an awful lot of things that you can measure that have standardized units. But what is the stuff that we measure? And sometimes people talk about business value. Or they just talk simply about value. The problem is with the word value is that it's not entirely clear that what you value is what somebody else values. Yeah? Do you value work-life balance? Or is somebody talking about valuing money? Which leads to this one. Yes, the planet got destroyed, but for a beautiful moment in time, we created a lot of value for shareholders. Yeah, clearly not much value elsewhere. But the notion there is, even with that, that's value for shareholders. What about value for the company directly? What about value for the customer? These are all financial in some way. But there's another thing here that we need to be very, very careful of. When people talk about prioritization with respect to business value, there is a problem with this. This is a very standard mantra in the Agile space. You should prioritize your features, your requirements, with respect to business value. That sounds brilliant. There's only one problem. It's impossible. Or actually, no, it's not completely impossible. If you have a time machine, which I do, clearly, if you have a time machine, you can do this. Because how do you know the business value of something? Well, in the future, I can look back and tell you, well, that was worth this. But now I can't tell you what the business value is. I can tell you what an estimate of the business value is, but that is entirely different. Estimates are not the same as the thing that they are estimating. Estimates are probability distributions, they are ranges, there are lots of different ways of looking at it. So when somebody says we are going to prioritize by business value, you just put in, no, you're going to prioritize by an estimation of business value. You need to add that note of caution in there, because an estimate basically tells you that there is information that we are using in order to get a range of results, and we could be wrong. We could be wrong in a very good way. We could also be wrong in a very bad way. But you are prioritizing with respect to estimates. This should add a note of humility. So, what else can we do? Well, lines of code? Yeah, this is what code generators were created for, to game that. Yeah. So no, that doesn't work out. So eventually people settle on very abstract units. Things like story points. There's a problem here, though, which sometimes people don't realize they're walking into. If we do a very simple bit of dimensional analysis, time is measured with respect to time. That's cool. What are story points? Actually, although they're not supposed to be, they end up being translated via a conversion rate to time. So you are measuring time against time. I remember pointing this out to a Scrum Master once. It was just, I was looking, he was taking such care over doing this manual plot on a wall. Such detail, such care and attention. It's one of those things, pull back and look at the big picture. You're plotting time against time. What does that actually mean? I mean, it does mean things, it just probably doesn't mean what you hoped it meant. It's not an indication of speed, it's an indication of utilisation. Yeah, in an 8-hour day, if I spend 5 hours working directly on product work, then my utilisation is 5/8. Yeah, 62.5%. So that's okay. Now, is that useful? I don't know. It's a figure, it's a number, but I don't know if that's what we want. Alternatively, it gives us a quality of estimation. How good are our estimates? So that's another thing that it could be measuring. But the one thing it's not measuring is how much stuff we've actually got, how much capability our system has, how much functionality it has. So it turns out that if we actually want to develop products that have appropriate quality and get delivered in appropriate timeframes, and importantly have appropriate longevity. Because it turns out that our obsession with, I need to hit the next release, need to hit the next release, does not balance out well with the idea that this is a game that continues. You don't actually need to hit the next release, you need to hit all of the next releases. That gives you a completely different perspective. But humans are not very good at that. That's what caused the 2008 credit crisis. There's a technical term for it, intertemporal judgment, I think it is. Yeah, the ability to balance trade-offs at two different points in time. Feel free to drop that into a meeting at some point. I think our intertemporal judgment was whatever. So that sounds good. So we need to pause a little bit. So how are we going to pause? So here's the OODA loop. John Boyd, a friend of mine, John Jagger, often talks about this one. He introduced me to it. Boyd was a US Air Force pilot and kind of wrote the book on aerial combat in high-speed fighters. And as is often the way, most things that are military end up somewhere in business speak at some point. In the 1990s, Sun Tzu's Art of War was a must-read for people in business. And we've kind of moved to other various things. So OODA's kind of interesting because there's this whole notion when people think, oh yeah, fighter jets, they're thinking Top Gun, and it's all about the need for speed. It's all about the speed. But actually, when you look at what they're doing, it's very different. Observe, orient, decide, act. It turns out that most of this is not about the bit that you see or the bit that is dramatized. There's a kind of like, okay, what's going on? Where do we actually want to be? How are we going to do that? Now, I'm going to rotate this through 180 degrees just for fun. Now, I'm going to rotate it through 180 degrees because John and I were once running a workshop, and everybody collects their own favorite loops, and he had the OODA loop, and I tend to favor a different loop, and we were trying to decide which one should we include. And it was only when I rotated it, I suddenly thought, wait a minute, these are the same. PDSA, Plan, Do, Study, Act, sometimes called Plan, Do, Check, Act. The word act means something slightly different in this case. It's the do in Boyd's OODA loop. But the basic principles are surprisingly similar. And what is interesting here is there is a notion, it just starts in a different place. It's like a slightly different mode. But here we have the idea of we are going to plan. And when we talk about plan, I use the word plan in its broadest sense. Plan can refer to something in space, a building plan. It can also refer to something in time, a schedule. So going back to the relativistic fun, this is space-time, okay? So plan basically means, I think we're going to do this. And I have a hypothesis. I believe we can do this. We're going to do it. Then we're going to reflect on it, study it, and then we're going to act on it. Now, what is interesting here, historically, this is the Deming-Shewhart cycle. Originally, it was formulated as Plan, Do, Study, Act. Many people know it's PDCA, Plan, Do, Check, Act. But one of the things I like is the word study. Why do I like the word study? Because it's slow. Yeah, if you just think about it, have you checked that? Yeah, checked, done. Study, ooh, that's going to take a bit of time. Yeah. So my older boy last year did a whole bunch of exams. My wife and I did not merely encourage him to check his work, we encouraged him to study. Yeah, there's a really big difference. One takes a lot longer than the other, but that's the idea. You're supposed to go into it in depth. Now, the problem here is that is a deliberate act of slowing down. The other problem is visibility. If you look, the things at the top half are highly visible. If you think about what a team is doing, I can see planning, I can see the consequence of planning. I can see doing, I can see the consequences of doing. But studying and acting on that and trying things out, that's a little less visible. And because it's not visible, humans are not very good at dealing with things they cannot directly see. We're great with physical things that we can kick, but we're not really good with stuff that is less visible. Time is a less visible thing, for one thing, but as is study and act. Now, we might say, well, this is all very well, but this is all very recent in terms of how we appreciate this in the software industry, that typically the tyranny of software development has been, since the 1970s, the company culture is dominated with plan, do. Not plan, do, study, act, but plan, do. We do a lot of planning, then we do a lot of doing. Okay, that's a sequential process. That is a waterfall process. So yeah, it's difficult to throw this off. We're only now learning that software development is more nuanced. It's filled with discovery and observation. Yeah, only now learning. So, software engineering is a term that dates back to the mid-1960s. It was not invented for this conference. This is a landmark conference that nobody ever reads the proceedings of. So a couple of years ago, I decided I would read the proceedings of it. I'm one of those kind of old-fashioned guys who likes to read the things that he cites. I know it's very unfashionable now, but I just thought I'd sit there and read what they actually said. People normally cite this as being the birth of software engineering. Yeah, it wasn't. As creating the word software engineering, as encouraging us to use plan-driven metaphors, as the origin of the phrase software crisis. It was the origin of the phrase software crisis, but there are about 2 pages in the whole proceedings dedicated to that. Nobody ever talks about it in the rest of the conference. Okay, so we've got a very distorted view of what goes on here. And one of the greatest revelations of this was this. And it turns out that Andy Kinslow is not the only person in the document to say the design process is an iterative one. There are loads of people. I can literally fill a whole talk with quotes from that paper that indicate that we must be very careful about trying to take a strictly plan-driven approach. That it's filled with this. So we lost some knowledge somewhere, I would say. And people often wonder what happened. What happened in the 1970s? I don't know. Flares, disco, you know, are these to blame? However, this also tells us something else, and this is where it starts getting interesting. So one of my favorite authors, Neil Gaiman, observes you have to finish things. That's what you learn from. You learn by finishing things. Now, if I have a project that I'm going to spend 18 months on, I have one point of completion in 18 months' time. That is my major point of learning. We start the project, we will never know less in that 18-month span than we do at the beginning. It is not, we will never know less. We might feel increasingly ignorant as we discover more, but that's a relative knowledge. Our knowledge is actually growing. Our appreciation of what we don't know also grows. But we will never know this at the beginning. If we make all the critical decisions there, that's not so smart. But there is a point here that the main point of learning, the main point of feedback, when we go, aha, and there it is. So perhaps we should finish smaller things. We should finish more often. We should finish less ambitious things, and that will allow us more piecemeal growth. A classic example of piecemeal growth is something like refactoring. Oh, I really ought to update this. Martin's come out with a new edition of refactoring that uses JavaScript instead of Java. So if you wanted evidence that we are living in the end times, apparently that's it. But there is a notion here. Sometimes people reduce refactoring to simply just like it's a shortcut that I do for simple things like renaming. And renaming is a very powerful idea. Renaming is a reflection of our own learning, but there's a really important thing here, is that refactoring is much broader. It is a deeper recognition that design has both a proactive and a reactive element. It's like I offer something, I create something, we see how it works out, and then I respond to what I've now learnt. So design is not a moment, it is a process that is ongoing. But if we look at this, improving the design of existing code is the subtitle, and we need to focus on the code. But we need to be very careful with the word code, because we often have our own favourite default definition of what we mean by code. And our favourite default definition is normally whatever my main programming language is, typically the one that appears on my CV, whatever my main programming language is, then that is the code. So if I'm a C# programmer, then that is the code. If I'm a Java programmer, that is the code. All that other stuff, oh, the little bit of JavaScript at the front end, oh, that's not code. All that XML, I always love it when people say, oh, you might, if those with long memories may remember, there was a period 10, 15 years ago where the whole idea, well, Sun was still around, so that kind of dates it. They talked about 100% Java. You have 100% Java. It's just like, I remember looking at, it's just like, you kidding? If you take away the XML, there's no system. You have just bits of Java. The XML is holding the thing together. Okay, so these systems were never 100% Java. They were kind of mostly your XML. And all your config stuff, all your tests, in other words, all of these things, and the list goes on, they all use a formal notation. That is your code. Your build scripts, guess what? They're code. Okay? All of this is code. And more precisely, we can actually look, and with a little bit of wordplay, this is codified knowledge. This is a different way of looking at what is a code base. A code base is a knowledge base. And we don't appreciate that because when we often think of it as this is a production artifact, it's a specification, it's all kinds of things. But what if we consider this to be a repository of knowledge? This is how we believe the system is built. This is what we understand of the domain of the problem and how we understand the technology and our decisions, our design decisions to do this. This is our current state of thinking. And this is effectively what we're saying here is this is almost like an executable Wikipedia. Okay? And therefore it tells us that the very act of development is centered around knowledge. This is knowledge formulation. Now, I've done this with a couple of teams where I've mentioned this, and they've kind of looked a little bit nervous. They say, sorry, so you're saying our code base is a reflection of our current knowledge. Wow, we think messily. Okay? With the problem that we have with a code base, when we recognize it's codified knowledge, is that when I go into the code base, what I see is what we currently think, what we thought 6 months ago, what we thought 6 years ago. And when I say we 6 years ago, it's people I've never met. So in other words, the past and the present are simultaneous, and we're kind of trying to, most of the time, we're trying to negotiate the past and the present together, and that becomes difficult. It's made harder by the fact that humans are quite capable of holding contradictory beliefs simultaneously. This is difficult for a code base, yeah? Even in the presence of maybe. So what do we learn? What do we learn? We learn is that, therefore, if software development, if one of its goals is codified knowledge that is executable, then the very process, what is the process of acquiring knowledge? The process of acquiring knowledge is learning. Although, feel free to use this phrase, when you're talking to higher-ups and, on slides, because knowledge acquisition sounds so much more, I don't know, it's got impact, whereas learning sounds, yeah, my kids do that. But we're in business, we do knowledge acquisition. Yeah, my children merely learn. They go to school to learn, but we are in business. We do knowledge acquisition. That has business value. And obviously, if you can work the word synergy in there or something like that, then that's great. We've got a knowledge acquisition process that synergizes and leverages the assets of the team in order to fulfill business requirements, thus attributing value. You can keep this going. You'll pretty much tab complete this one, yeah? I will wash my mouth out afterwards. I think that was disgusting what I just said. I'm supposed to like English, so yeah. Now, how do we get learning? Now, here's an important thing, is that I've been using the first person plural, we. I'm referring to the people in the room, but I'm also referring to the notion of a team. This is an act of communication. Learning happens through communication. That's how we pass knowledge between ourselves. And communication, there are many different channels of communication that we have. We have spoken communication, we have visual forms, whether we're talking PowerPoint or sketches on a whiteboard. But we're also talking the code, we're talking emails, we're talking all of these things. All of these things should be considered to be acts of communication. When I write a test, am I merely testing that something is okay, or am I trying to communicate to somebody what we anticipate, and this is my understanding of this? I'm trying to communicate my understanding. It doesn't mean I'm right, but I want to make it, I'm playing an open-hand game. Okay, I want to make sure that here's what I want you to see, this is what I'm thinking. I could be wrong, but if I show you what I'm thinking, you'll be able to see. But if I hold it close, then you won't. We don't know what's going on. It also means, because it all sounds lovely up until now, it's kind of like we're all living on a commune, producing knowledge, this sounds fantastic, and it's all harmony. Humans are not, we kind of resist the whole idea of complete cooperation. So there's a social negotiation. Now, this is quite an interesting one, because then we start realizing that a code base reflects not merely the rational things and not merely the accidental things. It reflects social structures, social negotiation. Coding guidelines are often social negotiations. Okay, this is really interesting, and therefore design reflects that. But there's another aspect here. What you then create is a model of participation. Now, we've got another phrase that we use for model of participation. It's called software architecture. And software architecture is not just a technical construct. What you're doing is you're basically saying, this is how we work. This is how we work together. This is how you're expected. So with this tooling and this code, this approach, this is how this team produces stuff. This is how we are able to contribute and move things forward. So you're actually defining a future path. It's a model of participation. So this gets right to the heart of the matter. It's about us, and speed is not really the right way of looking at it. What we're talking about here is effectively collective intelligence. Okay, so I was interviewed a couple of years back on something. I said the biggest advantage of autonomously working teams is risk reduction through increased group intelligence. Risk has a formal definition in the sense of exposure. It is exposure to uncertainty. Okay, so it's not merely a probability; it's whether or not you're exposed to that probability. That is the issue. How do we understand all the possible things? When we're building software, there's an awful lot that's new. In fact, this is the point of software. Software is the production of novelty, production of variation. By definition, even if you use a whole bunch of standard tools in a standard space, the software you're creating is in some way new. So what are the risks that you're engaging in? And it turns out some of the risks are to do with predicting the future, which we're not very good at. But this is the notion, if you have more people, you want to increase your intelligence. That's what a group of people can do. If your goal is knowledge, it's not typing. The goal is knowledge. How do you get a lot of people to create a body of knowledge that is really very good? So there's little correlation between a group's collective intelligence and the IQ of its individual members. Now, if you've been watching the British Parliament the last few weeks, you can see this in action. I even suspect that it is possible. I think I've always been told that IQ is a positive number. I begin to think it might have a negative domain. However, the thing about this one, so therefore there's a notion here, and this is very important to appreciate, that if we're trying to make a group of people intelligent, it's not just good enough to get a bunch of people together. That does not create that. And that there are some subtleties that can work against us. This one. If a group includes more women, its collective intelligence rises. Now, this one came out of a piece of research. I came across this in 2011. And what was interesting is the research was not setting out to look at that specifically, but it was an interesting result. And obviously, looking at you, I can say you could be smarter. But there's a broader thing here. It's a general one of diversity. Diversity has many aspects. One is fairness and representation, but there's another one here. When we talk about diversity, what we're actually saying is that if we all think the same, then we're not really thinking, are we? What's the value of having, N people thinking the same way? You could have had one person thinking the same way, and that would be fine. It would be cheaper. If you're going to get something wrong, you might as well do it cheaply. Fewer staff. But there's a notion here. We have a habit of recruiting in our own image people from our background, whether we mean our background to be an educational one, whether it's an ethnic one, whatever it means that suddenly you've got a lot of people that think much more narrowly. If you want group intelligence, you can't have the same people. You can't recruit from people who are all the same age. As I get older, I notice the age thing a little bit more. I go to some companies and I think, I'm the youngest person here. That's worrying. And I go to other companies and I think I'm the oldest person here, and actually I'm the same distance from all of these people in terms of age. Oh, they're all the same age. That's not good either. You go to companies, they're all computer science graduates. There's the same thing. What you're doing is you are thinking the same. People from diverse backgrounds might actually alter the behavior of a group social majority in ways that lead to improved and more accurate group thinking. There's a notion here about sometimes there's an enforced objectivity, but also there's a notion of it changes the communication style. If you remember, a few slides back, I had the word communication. How are we going to trade stuff? It breaks assumptions. Assumptions are difficult creatures because you don't know you have them until they are contradicted. Yeah? Think about it for a moment. How do you know that you have an assumption? Normally you don't. And then somebody says something and you say, I had assumed that. At that moment, in that moment, you have discovered you had an assumption. So assumptions are discovered by contradiction. So if somebody says, right, we're going to write down a list of project assumptions at the beginning of the project, you go for it. It won't be complete. It'll be completely wrong, actually. It'll be the assumptions that you've discovered so far, which is not bad. It's just that compared to the assumptions you're about to discover in, let's say, take the 18-month time frame, you are going to discover a lot more assumptions. And those are going to be from those moments where somebody's go, oh, I'd assumed that. Right, that was an assumption. So there's a notion here that you have a blind spot. You can't see your own assumptions until they come into collision with something. So what we're learning here is that group intelligence is not simply about number. And it's a very subtle creature. You can get this one wrong. Wisdom of Crowds by James Surowiecki, 2003. He gave us a very simple set of criteria, which I think is still quite useful. 4 conditions that characterize wise crowds: diversity of opinion, independence, decentralization, and aggregation. You can't all think the same way. But also, you have to be independent. You have to be able to think independently. Now, this one's quite difficult because humans are social animals. We tend to converge on things. It turns out that in economics, there is this idea of humans as rational but selfish and independent. The problem is, we're not like that. That's not actually how it works. We are strongly influenced by family connections, friend groups, and all the rest of it. So independence is a very difficult thing to achieve. This is one of the things that can lead to groupthink. Even when you are thinking differently, you can accidentally converge on something. Again, I refer to the UK Parliament. Decentralization. Importantly, you need to be drawing from different, it's not just enough to think differently, you actually need to be drawing from different things, different resources, different bodies of knowledge. That's kind of important. Now, all this is great, but it turns out 3 out of 4 is not enough. Because somehow you need to bring it all back together again. Aggregation. Where do we aggregate all of this stuff? Well, that's in conversation, that's in code. The code is a place for aggregation. Remember, it's a model of participation. This is where we put our knowledge. So this is interesting, because one of the things we're seeing here is that this is not really about speed. This turns out to be about people and these relationships. If you like, it's individuals and interactions. Turns out to be really rather important. But, human beings are obsessed by very simple things, the guy who's currently in the White House seems to be massively obsessed with size. And in this, he reflects a number of other obsessions that we find in business and in the Agile space. Size. But to be precise, I'm going to use the word scale, because that is the word that gets used all over the place. Safe, scalable Agile framework. Less, large scale Scrum. We are obsessed with this. There are talks on Agile at scale. Everyone's talking about scale. Now, what I would like you to do is next time somebody says, how do we scale this? I want you to throw in there's something missing from that sentence. There's an implied thing. Whenever somebody implies something, or it's tacit, it's not explicit, see if you can just sort of nudge it slightly. Yeah, can we scale this? Just ask up or down. That should stop the conversation. And this is interesting because there's a hidden assumption there. Now, that hidden assumption, a couple of years ago, my oldest son did a lot of CrossFit. And what I found absolutely fascinating is that in the CrossFit world, the word scale is used. But it means exactly the opposite of the way we seem to use it. If you scale an exercise, you scale it down. So perhaps you have an injury, perhaps you're recovering from an illness, and so perhaps you can't lift all the weights or do all the reps. Maybe you're new to it. Maybe you haven't built up the same kind of strength as other people, the same kind of skill, but you still want to go through the repetitions of either weightlifting or whatever it is. You scale it, but that means scale it down. So picking my son up, driving him back home, I'd say, how'd it go? He said, oh yeah, this is pretty good. I did what I did last time, but then there are a couple of things I had to scale, and he means scale down. So there's a notion here. Be very careful with these assumptions that we have with these words. So bigger is not always better. It turns out that if you're going to go fishing, the smaller boat is better. The larger boat is surprisingly difficult to do with this one. It also has a much larger turning circle. far less maneuverable, and uses up an awful lot more fuel. It's basically expensive to run. Now, this is all relevant because we have something else that the real world, the physical world, gives us in terms of our preconceptions. A friend of mine, Alan Kelly, made this very clear observation. Software development does not have economies of scale. It has diseconomies of scale. It turns out that we, and this is different to the way the physical world runs, we have economies of scale in the physical world. When I make more goods that are the same, then they should, per unit, get cheaper. That's the physical benefits of mass production. But what we produce in software tends to be unique and novel. So therefore, that doesn't really work. Adding more people does not automatically give you speed up. And in fact, we can really understand the whole speed up thing through just a careful understanding. So if I take as a baseline T1, this is the completion time for a piece of work for one person. Software development work, and I'm going to say, when I say completion time for one person, I mean they are doing everything. If there is testing to be done, they're doing it. If there's talking to the client, they're doing it. All the deployment stuff, everything. This person is doing absolutely everything. So this is our baseline. This is how long it takes one person to do this work. Then somebody goes away and reads Adam Smith, Wealth of Nations, and they learn about division of labor. This is brilliant because this actually works for certain things really well, typically physical things. So we end up with that. The problem is that you have to kind of pause for a moment and say, hang on, are we going to get perfect speed up? No, because it depends on the nature of the task. As you may know, if you try and get lots of people working in the same place on the same thing in a physical sense, they tend to get in each other's way. But also the nature of the task does not always divide itself up like that. And we end up with wait states. So P is the portion of the work we can do in parallel. If it's 100%, then it means nobody's communicating and everything that we're doing is independent. But it's going to be less than that, which means there are wait states. There are natural bottlenecks. It's the organization of the work. It also tells us that actually the lean folks are right on this one. Reduce your work in progress will give you better speed up. But this equation looks a little more familiar if we call it Amdahl's law. This also allows me to point out that human beings are not processors. Yeah? This is a thought experiment. I'm making massive simplifications here. But it is designed to just demonstrate that by default, don't expect massive speed up. This is just how we have organized our process. We haven't even started talking about the thing that we're building yet, which means there's another term. It turns out that we might need to talk to each other or communicate with each other, some of which is done through code, some of which is done face-to-face, and so on. And that means the worst possible case is where we're all having to talk to one another. This is a reflection of the architecture. If it's highly coupled, then everybody has to talk to everybody else. Or everybody's code has to talk to. Well, what do we do about that? Well, sometimes people get defensive, literally in the code, and they start creating barriers that defend them against other people's code or allows them to work more independently. That wasn't a requirement of the architecture, it's just a requirement of how people are. And there is an overhead associated with this. Now, lots of equations. What people really want is a graph. So here's a graph. And what you can see here is with some degree of satisfaction, if you have 0 people, it will take infinite time. Yeah? That's great. I mean, when somebody says, how's it going? Same as last week. You can always provide a consistent answer. But you can say, there are no bugs. Positive. That's good. Now, as we start to add people, we get a speed up. But then that starts slowing down because now we've kind of maxed out what we can reasonably get. You finished early. They finished early. That's not fair. We can't get more from this because people are communicating as effectively as possible for the nature of the task. If we start adding more people, then we actually are introducing overheads. We are now paying the cost of adding more people. We're not getting benefit from it. We're now it starts slowing down. Lots of consultancies operate out here. But the problem here is that we end up with a problem that we can easily characterize as this slowdown. We are paying a cost. It's actually half the energy that we're expending, half the effort, and the money is actually on the side effects of having so many people. It's actually nothing to do with the work. Now, what's interesting about this is that what we're saying here is that the actual size, guess what, by the way, the size of the code base will grow as a result. It turns out that it is surprisingly difficult to create a small code base with lots of people. And this is a reflection. Sometimes people think, okay, it's this kind of task, we'll need this many people, and it'll take this amount of time. But we fail to visit the assumption that the functionality doesn't tell you how much code or how many people. A particular point we find that there are, and this is one of the great things about software development, it's like a big Darwinian experiment. Look around the planet and you can actually see lots of different teams doing things that are quite similar, and they are very different sizes. And sometimes they're actually building something to the same specification or similar specification. And you're saying, well, how come this company's got 50 developers and this one's got 5? I'll tell you what, the route with 5 is probably going to finish first. Yeah? Because these other guys are carrying, it's like the rocket equation. It's like you're carrying most of your fuel. You're going to have to, the actual energy expended in getting everybody to work together is itself huge. And you can simply realize that it becomes a self-fulfilling prophecy. The more people you put on a project, the larger the project will be, irrespective of its functionality. And this is quite difficult. Now, again, I want to remind you that this is an approximation based on a simplified thought experiment. Because honestly, if the curve were as simple as that in the real world, you'd immediately know when you were slowing down. But you can't. So the real world is there's so much additional variability that you end up with an awful lot of stuff, local minima and local maxima, that you can't see that you're in. And so therefore, adding a person may slow it down, but adding another person may speed it up, or vice versa. It just depends on the people. You can't always tell where you are. But I was fortunate enough to see in action many years ago a manager who halved the size of a team. He halved the size of a team and brought a late project back on schedule. So that's why the company got rid of him, because he made everybody else look bad. I loved working for him. He was great because he used to sit there and mostly not apparent. He used to sit there and kind of think. He didn't do things with spreadsheets. He sat there trying to figure out what's actually going on with this team or this company. What could I do that would make this more effective or cause less interruption? This is now a much more normal thing to be encouraged, but at the time it was utterly foreign to me. I'd never seen anything like this. But he made all the other managers look bad, so they kind of got rid of him. That's how people work, disappointingly. Okay, so I mentioned Christopher Alexander earlier on as being the father of the patterns movement. But his work in the 1960s actually was also quite interesting and quite provocative, and a number of people were inspired by this in an interdisciplinary sense. This book, Notes on the Synthesis of Form, so my copy of it here, he talks about how systems of things or anything evolves. And he says, we may therefore picture the process of form making as the action of a series of subsystems, all interlinked yet sufficiently free of one another to adjust independently in a feasible amount of time. In other words, there's this idea, either in the software or in the people, that you have groups, but there's a kind of, don't couple people too closely, just allow enough variation, because as they learn, as they try things, they will introduce variation. And if everybody couples too tightly, then that will ripple out. That means you end up with everybody having to talk to everybody else. And he says it works because the cycles of correction and recorrection which occur during adaptation are restricted to one subsystem at a time. What I find fascinating is that this was cited in the 1968 software engineering conference proceedings. It was cited in multiple locations. This was very influential, and this was people saying, we need to partition our systems, but also our teams, so that as we learn, things may change. These days we use other terminology like refactoring and so on, and a very strong emphasis on modularity. Again, modularity was a word that was used extensively. But turns out that, so here's a sort of visual representation. In doing some work, it was only when putting together a talk that I suddenly realized I used this. Right next to it was this slide. It turns out in the 1960s, everybody was drawing bubble diagrams. In the 1980s, people started drawing rectangular diagrams, which came to dominate in the 1990s. I look forward to the next decade and seeing what shape. We've had hexagonal architecture the last year. What are we going to choose next? I'm really excited because it turns out there's loads of shapes in maths that we have yet to explore. Okay. So, but what this one is a picture. This is taken from Melvin Conway's How Do Committees Invent paper. This is the paper that gave us Conway's Law. And very importantly, he was interested in this stuff. The basic thesis is that organizations which design systems are constrained to produce designs which are copies of the communication structures of these organizations. A lot of people miss that subtlety, and they think it copies the organizational structure. No, it copies the communication structure of the organization, which may or may not correspond to the magic diagram that shows you who's in charge of who. Yeah? Humans are a little bit messier than that. We communicate in ways that are defined by geography, by friendship, by how long we've been at the company. I would expect somebody who's been at a company for 20 years to have a very broad communication network compared to somebody who's been there for 2 years. So we need to look at that. But also, what I find interesting is that some people have referred to the idea of I noticed this a few years ago. There's an inverse Conway or a reverse Conway maneuver, which sounds really cool, which is where you reverse the idea of Conway's law. These people did not read Conway's paper. This is exactly what he says at the end. He doesn't just say your software architecture is going to be is a victim of your organizational structure. He tells you how to take control of it. He tells you, figure out what you want and then organize according to the need for communication. Organize your people accordingly. We want this architecture. Okay, how are our people organized? Who communicates with who? Oh, okay, well, that's not going to support this architecture, so maybe we need to change this or this. That's a really simple idea. Now, we're hitting this idea of Conway. So we discussed Conway quite a lot in the Poser 5 book, but we made a real observation. In referring to this as a law, the appeal is to the force that will shape a system, much as a physical law. It's not a law of the country. You can't break it, it's just there. So the force is there. How do you counterbalance it? And we can kind of look at this. Don't worry, this one's not going to fall out the sky. It's an Airbus, not a Boeing. Well, this is important because it turns out that the Boeing thing, Boeing 737 MAX, it wasn't really a software fault. It's actually a basic aerodynamic fault. The engines are in the wrong place for the structure. And it would help if they went back to the original four-force diagram that is used to illustrate this stuff. You've got gravity. Gravity, it turns out, is not really that negotiable. But importantly, when I get into an airplane and fly, I am not disobeying the law of gravity. So, look at me, breaking the law. No, that's not how it works. There is a delicate balance between a number of other things, which are mediated by the weight, the aerodynamics, and all the rest of it. That is what gives us aeronautics. Now, clearly, don't take this too literally, because this is about people and software rather than about something plain physical. But I'd like to make you think in these terms, that when you're talking about this stuff, there is a balance of things. There is a force that is exerted upon the team that is based on how it communicates by default. There is a driving thrust design effort, but that can be held back by debt. And your practice, hopefully, is the lift. Obviously, as I say, don't take this too literally. You can put your own favorite 4 things in there and you can rearrange them, but the idea here is to appreciate that there is an interaction between these, that there is a balance to be achieved, that it's not really that simple. It's not a simple one-dimensional thing. So, back to the basic physics. You can put a lot of force into stuff. You're going to put a lot of force on something. How much acceleration do you get? Well, the heavier it is, the less acceleration you get. M is for mass. M is for monolith. So this is your original legacy system. This is one of the very latest computers to roll off the Brexit production line. It's the state of computing in the UK. I believe we call it traditional computing. Anyway, it's a legacy system. We have no idea what it does, but a couple of times a year, it gives us the right answer to something to do with the sun. And people look at it and go, why did they build it? Just as you do with legacy system. How did they build it? What were they thinking? Yeah, it's exactly legacy. But M is for monolith, monolithos, one stone. It's immovable. And clearly what we're looking for is something that is more easily fluid, easy to rearrange. Small stones rearranged. Now, sometimes when I put this slide up, people go, oh, he's talking about microservices. You know what? If it makes you feel good, yes, I'm talking about microservices. Yeah? Honestly, I'm talking about any decomposition. Pick a decade, pick a modularity, class-based encapsulation, components, whatever. All of these are trying to say the same thing. Don't build one big thing. That's all they're all trying to say. Break it up into little pieces, subsystems that can evolve independently, and all this kind of stuff. It's the same message. But just doing that is not going to give you magic. You know, here I give you most companies' microservice architecture. So there's this whole notion. What you've got to do here is this is the debt, this is the friction, this is the whole idea that when we go F equals MA, A is for Agile, A is to do with rate of change. In the long run, every program becomes Rococo, then rubble. What we can appreciate is that when we are talking about this, it's not about the speed, it's about it's not even about the velocity, once we've clarified that. When we talk about agility, it is about it's the ability to rate of change. It's the next derivative, it's acceleration. Can I change my velocity? How quickly can I do that? It is not the velocity itself. It is how quickly can I change. That is what we mean by agility. So I'll close with this idea. You know, you want to reduce your mass, reduce your debt, reduce the drag on things. But I encountered this thought a number of years ago, which I thought was quite an interesting one. Why do cars have brakes? Now, there's a very simple answer to this, which is obvious and also correct. Cars have brakes so you can slow down. Okay? That's one aspect of it. There's another answer, which is not so obvious, but is also correct. Cars have brakes so you can go faster. Now, this is the more interesting one, because it's a simple thought experiment. How fast would you want to go in a car that had no brakes? It's like, fine, I'm good, I'll walk. You know, there's a point here. When we start talking about a number of these practices, and people say, oh, you know, but if I do this, if I do code reviews, if I do unit testing, if we do a retrospective, if we do this will slow us down. Uh-huh. And sometimes people come to me and say, well, Kevlin, people keep saying that this will slow us down. And what they're looking to me is the answer, no, it's fine. And I say, yeah, it'll slow you down. They go, oh, crap. But that's a good thing. It slows you down over a particular thing, over a particular time horizon. Remember, time is the bit we're not very good at. It slows you down over a particular time horizon so that your broader time horizon becomes faster. I don't actually care what happens in the minutes, the hours, and the days if we slow down a bit. If we're playing the game of software development, normally what we're producing lasts and lives in the months and the years. That's the bit that you want to be hitting. What happens in the little level, that's maneuvering. That's finding your direction. So, with that thought, I hope that's convinced you that agility is not speed. Thank you.